Hi, welcome back to the channel. Thanks for tuning in today. Exhaust gas temperature sensor probe. I use these, of course, they're on all the airplanes. I use them on the run stand here in the shop, and one completely stopped working. The other one was intermittent. So it's time to buy two more probes. Long story short, I'm taking this apart. I want to find out why it broke, why it stopped working, and see if I can repair it. And I did. So I've got one completed already, and I'm going to do the other one now, and I'll show you how I repaired this so that I can use it here in the shop. And I also can test the accuracy and make sure it works properly. So follow along, and I'll show you what I learned about these exhaust gas temperature probes. So this is the Westac instrument that I have on my run stand for the 2-strokes. And of course, we can see we have it labeled mag and PTO. I think that's pretty important. So something that you may want to think about. It's all fine when both cylinders are exactly the same, but when one goes off, you need to know which one it is. It's going to make it a lot easier to figure out where the issue is. Anyway, these have a particular set of specifications where the probe must match the instrument or it will not work correctly as far as accuracy goes. You can put the wrong probe on it, it'll show a temperature, but it won't be right. So I'll explain how that works as we go along. Like all things, before we can do any diagnosis or consider doing any repairs on it, we need to understand fully how the system works. So how does our exhaust gas temperature system work? Just let me use the example of just a simple voltmeter. So this is a voltmeter, and I'll put the needle in here, and the needle is pointing straight up. It has two wires. It has a positive and a negative, and we're going to hook it up to a battery that is 12 volts. Well, how does this voltmeter know where 12 volts is? It's been calibrated because the manufacturer, the manufacturer wanted the needle to point straight up when it's at 12 volts. So it's calibrated for when it receives exactly 12 volts for the needle to point straight up. And of course, it would be marked as 12 volts at the top, and then 14 and say 10 over there. So that's how this system is going to work. So voltmeter calibrated, so when it receives 12 volts, they wanted the needle calibrated straight up. It is. So that's 12 volts. Okay. Now let's move over to our exhaust gas temperature, and let's see how this works. So in my example, they wanted the needle to be straight up, and we'll get to the reading in a second. So now we need a power source. Well, we certainly don't have a 12-volt battery because this is what we have. And this is the white and the black that go onto the meter. So let's take the wires and we'll run them from the meter down like this. And they are going to go together in this braided harness down here. So the two wires come down like so. Then they go into, this is just my crude little probe that it goes into. And this is the exhaust manifold here. And we have, I'll use my little flame here. So we have heat going this way because the engine is over here. Okay, doesn't matter which way it goes. But anyway, now, so we're applying exhaust temperature to, and this needs to go up here higher because that's where it bolts on. And then there's the nut part at the top. Okay, so this is what we see with this one. This is the idea, right? So it's like this. Now the tip of the probe should be in the center of the exhaust flow. So in other words, not all the way to the bottom and not just barely in. It should be in the center of the exhaust flow. Just a note for anyway. Now, at the end of this, these two wires are actually welded together, and there's a little bead, or there should be a little bead or a ball on the end. This right here is where it actually receives the heat and produces voltage. So how does it produce voltage to make our voltmeter has to move back and forth? Well, how does this work? Well, we have inside, where you can't see, inside the braid is yellow and red wire. They're different components, materials. So the yellow is the positive, and the red is negative, because because it has two dissimilar wires joined together here, it's going to produce a voltage, and it's going to make a DC voltage, just like this car battery did over here. And this was calibrated to point the needle straight up and say 12 volts. So right now the engine's running and it's producing 1000 degrees Fahrenheit exhaust gas temperature. So how much voltage then is this meter going to receive? It's going to receive this is for a K-type probe. So this is K-type. There's differences. So we're talking about K-type probes on this example. So it's going to receive, the voltmeter is going to receive 21.31 millivolts. Okay, so it's working in extremely low voltages. I mean, it can't produce the power that you're going to get out of a car battery, but it definitely, with temperature, it changes in how much it produces. So they've calibrated this instrument so when it receives from the voltage produced 21.31, remember, millivolts, then it's going to be calibrated to say 1000 degrees. And then, of course, it's going to be like 1200 over here and 800 over there. Now, what's the difference in, that's at 1000 degrees. So say we want to test this, and we want to test this in something that we can do. So we can put it in a pot of water, because we're all able to boil some water. And if you have a good thermometer, just below the boiling point, so at 200 degrees Fahrenheit, when this is disconnected, so we just have the probe, on our workbench. If we, wrong one. When we have the probe on our workbench, if we immerse this end in the pot of water, sort of in the middle of, so here's going to be our pot of water on the top right here. And our heat source, this is another one of my great flames here. Our heat source underneath, we don't want it to touch the bottom. We want to suspend it somehow, so the tip is, say, around about here. So whatever you need to do to hold it in the water, because we want this to be heated at 200 degrees with the water, not by the heat of the oven, or the burner that we're using this on. So at 200 degrees, so just below boiling, we expect to see a voltage of only, 2.87 millivolts. So here's the span on this. It works with such low voltages. 200 degrees, 2.87. 1000 degrees, 21.31 millivolts. So very interesting the way it works. So the hotter that this point right here, this little bead of weld gets, the more that this will produce a voltage in millivolts, and more it will deflect towards, say, 1200 degrees, or take away some heat, close the throttle, no real work is being done, or not as much work is being done, the exhaust cools off, and it'll deflect down and it'll read 800 volts at whatever the voltage is for that. So we can actually test these just like this in water and see what the output is. And the other thing that we can do is we can check the resistance on it, which is something that you can do. So here is a probe. This one is actually a real Westac probe, and you can see because the end of it is crimped down here. This is what they call a grounded probe. Anyway, let's hook up the ohm meter and let's find out what we get. Now, when we're checking the ohms in these, so say your E.G.T just stopped working. One of them dropped out, doesn't do anything. Right on the airplane at room temperature, so 68, 70 degrees, then we should get right there, 2.5 ohms. So there's another spec right there. So we're going to say at 70 degrees, we'll get 2.5, and this is ohms. This is resistance. So now at this point, I can say, well, okay, it has the capability of that. That means I would expect this probe to work because that's another calibration, same as this is. 200 Fahrenheit, 2.87 millivolts, 1,000. We can't test this off the airplane because how are we going to know we're making 1,000 Fahrenheit? I can't do that. So I have to go with the pot of water because I can control the temperature. And I can also, when I know that this is, the shop rate today is 68, 9, maybe 70 degrees, and this has just been sitting on the table here. So I'm going to say this is at 70 degrees, and it makes 2.5 ohms. So I would say, okay, that's a good one. However, when I run it, somewhere the gauge will work, and then it'll drop out, and so it'll deflect and go back to where it should be. So I can't really rely on that then, can I? So where could it be broken? Well, from my experience, I've never seen one broken down through here. Where the issue always is in this end. So this is where I'm at. As I was saying, I have to just keep buying new ones when they break because, you know, they move them around, they get bumped around a lot, and they're really quite robust, but I guess the way I'm handling them or using them, not so much. Anyway, now, to get back to that, let's have a look and see what's actually inside here and how you take this thing apart. Now, as I mentioned before about these probes that I was speaking about, a grounded one and they have non-grounded ones, I don't find any difference in the way they work in reality. Now, this one is an original Westac one, and you can see at the end it's smaller diameter at the end. Then this one here is just rounded on the end. So the difference is this one being a grounded one because the wires that go inside come right to the end, and the little bead in this thing here, I believe, is pressed, welded, whatever, so that the actual sensor is quite large, but this is the very tip. So when we put heat right here, this is when we're going to get a reading. So maybe a little more direct, maybe a little more responsive is supposed to be the difference. Now the other one is this style where we can see it's just right rounded on the end. And this one is a non-grounded one. So the contact point, which is inside, is just right inside the very tip. So it could be right about here, but it doesn't actually touch the body of it, the tube. Okay, so this one is welded, pinched, crimped, whatever you want to call it at the end. These ones, you can take it apart and see what's in it, but you'll never fix it because by the time you get this apart, it's destroyed. The ones that I repair here are the aftermarket ones, like I think this one was probably a Swift maybe. And these are the, well, they're the more economical ones. And these ones are sometimes pretty hard to get. So let me show you how you actually take these apart, or how I took them apart. And it's a good education. So if you have one of these kicking around, it quit working and you didn't throw it out, well, maybe you want to take it apart and just see what's inside. Okay, so let me get the other pieces and I'll show you where I cut it. Now, how I take apart which is the non-grounded one, the rounded end one, is this is where the nut goes here at the top, and I'll cut it just below these indents here where it's crimped together. So I'm trying to cut off this part of the crimp, and it leaves me with a tube after, just like that. So here's a rounded end one. Okay, and then I go inside and I just touch up the inside edge a little bit. Why do I need to do that? Well, when I cut it open and I get this top piece off where it's crimped, now I can slide it up the wires, and now what I'm left with is now if you've taken the nut on here and tightened it up so much that you've actually put a dent in it from this wedge here, you're probably not going to get it apart. So just be forewarned on that. If that's the case and you still want to take it apart, it's already no good. Just keep cutting gently down in the tube and separate it off because you want to see what's inside. Now, okay, so here we go, back in view here. So this is what I'm going to have. So yellow and red wires, the two go in. I've already cut the top off, and then I can slide this out. So what do we have inside? Well, we have this insulator that these slide into. So the wires are bare where they go in here. And so where is the bead actually at? Here's the sensing tip. So when it's assembled, they're kind of side by side, whoops, like that. So it doesn't touch the bottom, and it's not way up from the bottom, it's right at the bottom. So what I find with these ones is they don't appear to be welded together with a big bead on the end here. They're just, and it cracks right there. Now, it's not that I mishandle them a lot, but what does happen is, I know it does, when I'm handling them and the wires twist, see, I can twist, here we go. So I can twist the wire. See, it touches right now, and if I twist the wire a little bit, it moves away and doesn't touch anymore. So this is the issue that happens when it works and it doesn't work. It's intermittent. So I'm going to create a new bead on here, and then I'm going to put it back together again. So from now on, when that happens, then I can just fix them right here. So the reason that they really are very robust and last a long time on the airplanes is when we install them, we're into the exhaust manifold, and trying to get this thing to move. Here we go. So we're fixed in the manifold, and instead of leaving this wire to flop around, the cable part, we should put some nice gentle bends in it, and maybe we would put a tie strap right here, and maybe we put another one there, so that this can't twist around and move. I mean, these last a long time on the airplane. I have a problem with them in the shop because I handle them so much. But anyway, now I want to switch over and I'll show you how I weld the ends on these and make it work again. This is the wires that I learned how to weld it together with. See, on this end we're black and white. This is one of the aftermarket non-original equipment ones. And on this one, it is the two dissimilar metals, only of course, you can see it's black and red instead of red and yellow. Anyway, there's a difference right there. So if you can see where I put the two of them together, hopefully this shows up. And I got a pretty nice little bead on the end there. And I actually did that with my booster battery pack. So I didn't use a special machine for it. You can get a special machine for it, but if I'm going to buy the special machine to weld these with, I might as well buy a basket load of sensors. It'd be cheaper. Anyway, let me show you how I weld it together with a booster pack and a starter brush. Now, as you can see, I've stripped these back further. I scored it a little bit on the plastic with a razor knife and then just slid it off. But the idea is to make sure that you don't put any scratches in it. And then when we cut it, Of course, now it's not round anymore. So you need to dress the ends up a little bit with a file because we're going to put it through the insulator. And I don't want to break the insulator because you can't get those again. So that one doesn't quite fit yet. And this one, nope, still has a burr on the end. So I'll have to dress the ends up a little bit better. So what I've done here is I put a little bit of shrink tube over so that I can cover them up after. And then let's put these two wires through the little insulating tube. Now I've left myself lots sticking out the end, lots of, so if I get this on the first weld, then that's great. And if I don't, then I can try a couple more times before it gets too short. So let's set up and do the weld on it now. So that's my configuration right here. You know, it's pretty small to see. So I'm clamped, I got my ground on there. Here's my starter brush. So I'm gonna put that in the positive lead. This battery pack knows it's not hooked up to a battery, so you have to push the little button here to make it work. And now let's see what we can do here. So I've had success with brushing it sideways and coming in straight. So it's kind of a combo of the two. And I think that worked pretty well. Nope, it could be better. Okay, so let's carry on a little bit more here. Oh, beautiful. You probably saw that nice orange bead on the red hot orange bead on the end. That's what I was actually looking for. So yeah, that, oh, okay, let me try and make this so we can see it. And it's got a very nice bead on the end. That's what I wanted. So now I'm going to slide the insulator down and bring this in on the end, right like that. And now I can just take my shrink tubes down here because remember I left myself some extra here, so I can just take the shrink tube there and shrink it, and then we'll have something that'll work. So I'm hooked up here to check the ohms on it. It's 3.1 ohms. It's still a little bit warm from welding it, so I'll have to let it cool back to room temperature, and then I can make sure that it's calibrated properly. So here's the two completed probe ends, both re-welded. I put shrink tubing on them. And now how do I put them in so they stay back in there? Well, here's my tube. This is where we cut the end off, of course. Slide it back in and tighten it up. So I have the appropriate length on here that it needs to be inserted into the manifold to be in the middle of the exhaust flow. And then I've just welded a little tab on it, a couple little cutouts. And what I can do now is I can just slide this back inside until it touches, and then bring it back just a tick, and then I can tie strap it, and that's what's going to hold it together. So easy for me to service next time. So that's going to be much better. So let's see, pay attention to what I'm doing here. So that's at the bottom, and then I'll bring it back just a bit, tighten up the tie strap, cut it off. That one's complete and ready to use. Now I'll carry on and I'll do the same thing with this one. I have to weld a little tab on it. Then we'll test them. Now, as you can see, while they're finished, they're tie strapped on, they're ready to use. Now I've tightened these up and I'll be turning the whole unit to put it in. So when it goes into the engine, the whole thing will be turning, and I'll tighten it up by this. So, I mean, I'm not going to undo this every time and slide it in and out, all that other stuff like that. Could I use it on my airplane like that? Yeah, you know what? I probably could. Doesn't really look that bad considering they're fixed, repaired, but they'll definitely do what I want to do here in the shop. So now that that's finished, now we need to test these and find out, do they actually work properly? Because I need this probe and this probe to agree. If I'm trying to diagnose something, and my cylinder temperatures are off. Well, is it the engine, the way the engine runs, the carburetors? Is it these? So let's do the calibration process so that when I use these on an engine here in the shop, I know they work correctly. So now that I've got these all assembled, and by assembled, I mean these are tightened up here. I'll be installing the whole piece as a unit into the manifold here when I use them in the shop. But now I need to make sure that they actually are to specifications so that when I get a reading from either one of these probes, I know it's correct. So I'm going to, we'll do a couple of tests here, which you can do to verify your probe if you're curious, is my probe working properly? Is it giving me the right reading? Or is there actually something wrong and it's an erroneous reading? So let's do that. I have the meter set to ohms, and it's 2.6 on that one, ohms, and it's going to be probably really close, 2.7 on this one. Because this doesn't, yeah, 2.6, see, it's right on the cut point of changing over. If this had more zeros to the right-hand side, I could tell exactly, but for what I want, these are identical resistance, and that's what I'm looking for. It could be a check you could do on the airplane if you want to just check to see how close are they at ambient temperature. Say it's 90 degrees out. I don't know what the ohm resistance would be at exactly 90 degrees. However, they would both be exactly the same, correct? I mean, you haven't started the engine yet, so that'll give you an indication of whether they work or not. But room temperature, it's just switching back and forth. So here's my test rig here. I have a thermometer in the water, and again, the probe is about halfway. It's not touching the bottom. It's about halfway down in the water. The same with the thermometer tip. I want an accurate reading of the temperature at the tip of my probe. I'm at about 150 almost, and as you can see, I'm in millivolt scale here, 1.8 millivolts. It's going to come up, and what I'm looking for in the end is the spec from before, which is 200 Fahrenheit, 2.87 millivolts. Now, I'm either going to get 2.8 or 2.9 because there isn't anywhere here to get a 7. So we'll see what happens. So I'm at 200 degrees. I had to reposition the thermometer because it was a little bit too far down. That's why it's at a different place. At any rate, and I'm at 2.9. So I can't get 2.87, but 2.9, oh, I'll take that. So I would say that one is absolutely in calibration. So now I'll switch over, we'll check the other one and see if it's the same way. So I've just switched over to the other probe now, and the water is cooled down. It's about 185 or 6. And we'll let it warm up and see what we get when it hits 200. Now this just hit 200, and I have, as you can see, 2.9 millivolts, exactly the same as the other. So that's perfect. I'm really happy with that. So both of them check out with the ohms resistance when we did our ohms on them, and now at 200 degrees, they both check out exactly the same. So here's the very unscientific part of this. I don't have a spec. I have no idea what the temperature is, but remember, I want them to read evenly. So as you can see, I clamped them together. I got a propane torch. I'm not going to hold it at the end and try and make it red hot. I'm just going to hold it so that the flame goes by them. Oops. I can do this. And see what kind of increase, how soon it works, whatever temperature it is. And they're both in the same part of the flame, so I'm expecting I should get the same temperature. Well, that's very interesting. They both started to actually turn red, and I have an identical reading from both of them. So I'm thrilled. So now I know that these are calibrated, and I can use them, and I can rely on the information I get. So that was just by clamping them together and putting them at the torch. So exhaust gas temperature probe, K-type. Maybe that took the mystery out of what's actually inside of one of these things and how does it really work. Anyway, like, share, subscribe, all those other things. Thanks so much for watching today. See you again next time. Bye.